Welcome back to the GCSE Maths series. Today we're going to be taking a look at parallel lines and perpendicular lines. So let's get straight into it. So to describe parallel lines, these are two lines which never meet and they have something in common. They have the same gradient in the equation y equals mx plus c. And obviously if you've watched my video on equation of the line, we will know that the letter that represents the gradient in this formula is our m. This represents our gradient. So when lines are parallel, their values of m are equal. So as you can see in my example that I've given you guys, y equals 3x minus 4 and y equals 3x plus 7. So we can see our mx plus c here and our mx plus c here. We can clearly see that our two m's are equal. Therefore, our lines are parallel and never ever touch. Moving on to some questions now. A line has the equation y equals minus 2x plus 4. Write the equation of a line that is parallel to this and passes through the point 3, 1. First things first, we're going to remember our formula y equals mx plus c. And when lines are parallel with each other, remember that the m values are equivalent. And in this case, our m is minus 2. So we're going to write off our generic formula like so: y equals minus 2x plus c. Now we're told a coordinate. How we use this coordinate is to label the first number x, and a second number y. What we do here is we look at our general formula with the gradient and we plug in our values of x and y to specify the line. So plugging this in, we're going to get 1 equals to minus 2 times by 3 plus c. Now, expanding our bracket here, we get 1 is equal to minus 6 plus c. Plussing 6 on both sides, we're going to get 7 is equal to c. Now that we have our value for c, we can now look at our general and go y equals to minus 2x plus 7. And that is our equation of the line which passes through point 3, 1 and parallel to our original line. The next question asks us to determine whether two lines, 2y equals 6x plus 12 and 3y equals 9x minus 4, are parallel. Now, the way we do this is we first get our equations into our form of y equals mx plus c. As you can see, with the first equation, 2y equals to 6x plus 12, we have 2y on the left-hand side instead of y. We need to reverse this, and the way we reverse this is to divide through the whole equation by 2. So dividing everything through by 2, we get y is equal to 3x plus 6. That is our equation number 1. Now, looking at our equation number 2, we have 3y equals to 9x minus 4. On the left-hand side, we see that we have 3y. We need to reverse this to make it y, so we divide through by 3. So y is equal to 3x minus 4 over 3. Now, we now compare our m values, so 3 compared to 3, and we can see that the lines are in fact parallel. Okay, looking at our question number 3, we're told line A has the equation y equals to half x plus 5. Line B is parallel to A and passes through the point 4, 3. Find the coordinates of the point where line B crosses the y-axis. So this is a few stages in this question. So first of all, we notice that the gradient will be the same. So our m value will be the same because our lines are parallel. So we have our general equation for this parallel line as y equals to half x plus c. Labeling our coordinates, we have x and y, which we're going to now need to plug in to our equation to find our value for c. So 3 is equal to a half times by 4 plus c. So 3 is equal to 2 plus c, and therefore c is equal to 1. Plugging this back in, we have y equals to a half x plus 1. And that is our equation of our line. But remember, the question's asking us At what point, at what coordinates does line B cross the y-axis? So to think about it, when something is to cross our y-axis, so our y-axis is this one here, this line here, so we have our y and we have our x. When it crosses this point, x is equal to 0. X is equal to 0. So to find the point where line B crosses the y-axis, we have to plug in the value of x equals to 0 into our equation. So plugging this in, we get y is equal to a half times by 0 plus 1. Therefore, y is equal to 1. So our coordinates are going to be 0, 1, where x is 0 and y is equal to 1. Okay, moving on to perpendicular lines. So this is supposed to say perpendicular. So perpendicular lines meet at a 90 degrees. So these two lines are perpendicular and their gradients are negative reciprocals of each other. I know that is a bit of a chunky word, but I'm going to completely explain it to you guys right now. The negative reciprocal of something is to first times by negative 1, and then the reciprocal is to basically flip it. And what I mean by flip it, say we have x as just a generic thing. To flip it is going to be 1 over x. So we put it to 1 over. Now, y equals 3x minus 4 and y equals negative a third x plus 7 are perpendicular. The reason for this is because if we look at our two values for m, we notice that to get from 3x to negative a third x, we have to apply this negative reciprocal that we were talking about. First, we times by negative 1 to get it negative, and then we find the reciprocal and put it 1 over. Therefore, we get negative a third x. Okay, looking at some questions, we're told to find the equation of the line perpendicular to y equals 2x plus 1. And it passes through this point here. So, as we did in the parallel lines, we're going to have to first find the generic form of the line with the gradient perpendicular to our first line. So the way we do this is we take our m value of 2 and then we apply first the negative, so times by negative 1, well, times by negative 1, and we get negative 2. Then we apply the reciprocal, and we get this equal to negative a half x, because we put our value, so our negative 2, and put 1 on top of it and made negative 2 our denominator. So we now have our gradient function, so we have negative a half x plus c. Then looking at our coordinates, we have x and y like this. Plugging them in, we get 5 is equal to negative a half times by 4 plus c. So 5 is going to be equal to negative 2 plus c. Adding 2 on both sides, we get c is equal to 7. So our complete equation of the line is y is equal to negative a half x plus 7. Looking at our question 2, it asks us to determine whether these two lines are perpendicular. Remember in the parallel line section, the first step we had to make was to put these two equations into y equals to mx plus c. Now doing this with the first equation, we have 3y is equal to 6x minus 9. So dividing through by 3, we get what y is equal to 2x minus 3. Looking at our second equation, we have 2y is equal to minus x plus 12. And then we get, dividing through by 2, we get y is equal to negative a half x plus 6. Now, as you can clearly see, to get from gradient 1 to gradient 2, we have applied our negative reciprocal. Therefore, the lines are perpendicular. Okay, line A passes through the points 2, 1 and 6, 3. Line B is perpendicular to line A and passes through the point 7, 8. So we need to find the equation of line B. So we're going to have to work out the equation of the line. So we will label our coordinates x1, y1, x2, y2, and to calculate our gradient of this such line, we're going to get y2 minus y1 over x2 minus x1, which is going to be equal to 3 minus 1 over 6 minus 2, which is going to give us 2 over 4, which is equal to a half. So the gradient for line A is equal to a half x. Now we need to work out the gradient for line B. And remember, line B is perpendicular to line A, so we apply our negative reciprocal. So timesing by -1, we get negative a half x, and then putting 1 over negative a half x just gets us back to negative 2x. So our general equation for line B is y equals negative 2x plus c. Looking at our coordinates, we have x and y like this, and we plug them in to get 8 is equal to -2 times by 7 plus c. Therefore, c is equal to 8 plus 14, which is equal to 22. So the equation of line B is y is equal to -2x plus 22. Okay, that's going to conclude our revision video on perpendicular and parallel lines. I hope you guys enjoyed the video. Hope you guys felt like you've learned something. As always, please make sure to like, comment, and subscribe. And I'll catch you guys in the next video. Peace.